Hello my friends, and welcome back to the You Can Do TV channel. Corn processing line by Sweer is engineered to handle fresh market and vacuum-packed corn with high efficiency and product integrity. Workers manually arrange freshly harvested corn using laser guidelines to achieve the most uniform alignment before feeding it into the processing machine. Corn are fed into the line for husking, silk removal, and precise trimming to uniform length. The modular system supports gentle handling to minimize kernel damage, while adjustable capacities allow adaptation to different crop volumes. After alignment, the corn is carefully placed by workers into standardized boxes, maintaining uniform loading height and density. This integrated line ensures consistent quality, hygiene compliance, and optimized throughput for modern corn processing operations. What happens in the moments after sweet corn leaves the field determines everything you later taste on your plate. Sweet corn processing begins immediately after harvest to preserve sugar content, texture, and nutritional value. Truckloads of freshly picked corn arrive at the processing facility and are fed into high-capacity husking machines that remove leaves and silk within seconds. Husks are collected and recycled as high-quality silage, supporting a closed-loop agricultural system. The dehusked ears move along inspection conveyors, where operators visually check each cob. Premium cobs are diverted for whole cob products, while remaining ears are routed to cutting lines. Depending on the final product, automated cutters either trim the cobs or strip kernels from the cob with precise, high-speed blades designed to minimize kernel damage. Both cob and kernel products are thoroughly washed, then sent through blanching systems where they are briefly cooked to deactivate enzymes. Rapid cooling follows to lock in color, sweetness, and texture. Kernel corn then passes through optical sorting equipment, where cameras detect and eject any defects or foreign material. The finished corn enters industrial freezers operating between -5 and -10 degrees Celsius, freezing the product quickly to preserve freshness. Finally, the frozen corn is accurately weighed, packaged, labeled, and prepared for domestic and international distribution. At the heart of Puglia's tomato tradition lies a process where climate, technique, and timing work in precise balance. Production of Puglia's sun-dried cherry tomatoes and oil begins with carefully selected Pomodorini, harvested at full ripeness to ensure maximum sugar concentration and firm structure. Immediately after harvest, the tomatoes are washed, inspected, and cut, typically halved, to expose the pulp and accelerate moisture removal. Drying is a critical phase. The tomatoes are arranged on drying racks and dehydrated under controlled natural sunlight, or in low-temperature drying chambers that replicate traditional conditions. This gradual dehydration reduces water content while preserving color, aroma, and nutritional value. Salt is applied during drying to aid preservation and stabilize texture. Once the target moisture level is reached, the dried tomatoes undergo rehydration and acidification, often using a calibrated vinegar or brine solution. This step restores elasticity, balances acidity, and ensures microbiological safety. The tomatoes are then drained and carefully prepared for oil preservation. High-quality vegetable or olive oil is used as a protective medium, creating an oxygen barrier that prevents oxidation. Spices and herbs may be added according to recipe specifications, but the process remains focused on maintaining product integrity rather than masking flavor. The filled jars are sealed and subjected to thermal stabilization or pasteurization, depending on the production standard. Final quality control checks verify texture, oil clarity, seal integrity, and shelf stability. The result is a technically refined product that captures the essence of Puglia: intense flavor, controlled craftsmanship, and preservation through precision. Dica Conserviera e Scatolificio is recognized as one of the leading and most technologically advanced food canning companies in Italy, combining high-capacity production with strict quality control. The process begins with optical selection systems, where raw product is automatically sorted based on color to ensure uniformity. This is followed by thermophysical peeling and a second optical inspection stage to further remove defects. Throughout all phases, occupational safety is fully integrated, with automated systems minimizing direct operator exposure. The Sika can-making division operates with high-precision tinplate cutting, delivering consistent geometry, clean edges, and high throughput. Welding operations focus on durability, speed, and long-term reliability. Can formation proceeds through 3 critical steps: flanging to prepare the body for lid coupling, beading to reinforce structural strength, and seaming to securely join the can and lid. Every can is then tested using dedicated Provascatol systems, with any imperfect units automatically rejected. Lid production is equally advanced, featuring a unique sheet press model capable of producing up to 500 lids per minute. A dual mastic application system ensures correct sealant distribution, while camera-based inspection automatically detects and removes defective lids. Palletizing is fully autonomous, eliminating handling risks for personnel. On the processing side, continuous evaporators and a centralized thermal plant generate steam efficiently for production needs. 2 production lines enable output of up to 30,000 3-kilogram cans per hour, at 500 cans per minute. Quality assurance is supported by an in-house laboratory performing constant chemical, physical, and organoleptic analyses. X-ray scanners inspect every single jar for foreign bodies, while pressure control devices eliminate swollen containers. Annual output reaches approximately 25 million cans for the food service sector. Have you ever wondered what it takes to produce a consistently crisp, shelf-stable pickle on an industrial scale? The Mount Olive pickle production process offers a clear example of how raw agricultural products are transformed through controlled fermentation, precise processing, and rigorous quality control. The process begins with fresh cucumbers sourced from multiple growing regions to ensure supply continuity and size uniformity. Upon arrival at receiving stations, cucumbers are inspected, graded by size and quality, and transported to the processing facility in bins, barrels, or bulk loads. Bulk deliveries are unloaded using high-pressure water systems that minimize mechanical damage. Cucumbers are then routed into 2 distinct production paths. For processed pickles, the product is transferred into large outdoor brine tanks, each holding hundreds of bushels. These tanks initiate controlled fermentation, where salt concentration, temperature, and time are closely monitored to develop flavor, texture, and preservation characteristics. Tanks are typically filled during peak harvest season and drawn down as needed for production. Fresh pack pickles bypass fermentation. These cucumbers are washed, trimmed, and processed immediately to preserve fresh texture and color. Both product types enter the washing and cutting stage, where automated systems slice cucumbers into chips, spears, cubes, or leave them whole, depending on final specification. Blanching stabilizes color and texture before packing. Clean glass jars are automatically fed onto high-speed filling lines. Mechanical fillers distribute cucumbers evenly, while manual or assisted topping ensures consistent fill levels. Precisely formulated cover brine is mixed in large industrial tanks, with continuous testing of salt, acidity, and sweetness before being added to each jar. Sealed jars are vacuum-capped and pasteurized in multi-zone thermal tunnels, where temperature profiles are carefully controlled to achieve shelf stability without compromising texture. After cooling, jars are labeled, coated, tray-packed, palletized, and transferred to warehouse storage. Throughout the entire process, laboratory testing verifies pH, salinity, acidity, and flavor consistency, ensuring each jar meets strict technical and food safety standards before distribution. The Best Made Pickle Factory operates as a fully vertically integrated processing facility, maintaining control from raw cucumber intake to finished, palletized product. Cucumbers arrive at the Fort Worth plant and are transferred into large holding tanks for desalting and conditioning. Depending on product specifications, cucumbers are processed whole, sliced, or speared before entering the automated production line. A surge tank regulates flow to a vibrating filler that evenly distributes product into jars. Manual topping stations ensure consistent fill levels. Brining systems inject calibrated formulations, followed by steam capping to create a vacuum seal for shelf stability. Jars are rinsed, labeled, date-coded, case-packed, palletized, and stored for distribution. Fresh pack lines additionally cook cucumbers directly in the jar to preserve texture and flavor. The banana is not a tree but a large herbaceous perennial plant that thrives in tropical climates. In the Philippines, particularly on the island of Mindanao near Davao, Dulce cultivates bananas in both lowland and highland regions to ensure stable, high-quality production. Cultivation is supported by biotech laboratories, where propagation is carried out through tissue culture. Selected suckers are processed under sterile conditions, multiplied through several subculture stages, and hardened before nursery growth. After approximately 40 weeks, plants are ready for field planting on carefully prepared, well-drained land. During harvesting, bananas are picked green and transported via plantation conveyor systems to maintain quality. At the processing facility, fruit is washed, graded, packed, chilled to 13 degrees Celsius, and shipped in refrigerated systems to global markets, ensuring consistent quality from field to port. Under clear blue skies and within a rich natural ecosystem, organic banana production in Mexico is driven by skilled hands and disciplined agricultural practices. From planting to harvest, certified organic standards guide every operation, ensuring soil health, crop integrity, and product safety. Cultivation relies on trained teams who manage planting density, organic fertilization, and pest control without synthetic chemicals. Once the fruit is cut from the plant, a controlled post-harvest workflow follows, where bananas are carefully selected, graded, and packed to preserve freshness and quality. Logistics teams oversee responsible loading, refrigerated transport, and export handling to maintain optimal condition during global distribution. Committed to environmental stewardship and social responsibility, the company operates under Fair Trade International certification, supporting worker welfare and sustainable farming. This integrated approach delivers organic bananas with consistent sweetness, natural quality, and full traceability from Mexican fields to international markets. On the island of Mindanao, near General Santos in the Philippines, the journey of tropical gold pineapples begins with controlled plant propagation. Selected plant material is multiplied through tissue culture in dedicated laboratories, then transferred to nurseries, where root systems develop before field planting. Additional propagation is achieved using crowns from mature plants, while unused biomass is composted to enrich plantation soils. Harvesting is performed using purpose-built boom harvesters. Handpickers select fruit at optimal ripeness and place it onto integrated conveyor systems that load directly onto transport trucks. At the packing sheds, pineapples are washed under controlled pressure, inspected, graded by size and quality, labeled, and packed to market specifications. Finally, refrigerated trucks deliver the fruit to the port of Davao, maintaining cold chain integrity for export. Fruit Point, Costa Rica operates a highly technical pineapple production system built on precision agriculture. Field operations are guided by data-driven crop monitoring, optimized irrigation, and controlled nutrient application to maximize yield and uniformity. Integrated biological control replaces heavy chemical use, supported by in-house laboratories developing biocontrol agents and plant health solutions. Harvesting follows strict maturity indexing, with standardized cutting, handling, and rapid transfer to post-harvest processing. Organic residues are mechanically processed into biofertilizer and animal feed, creating a closed-loop system that improves soil performance, operational efficiency, and long-term agricultural sustainability. At Fruit Point, Costa Rica, the packaging process is engineered to preserve freshness, quality, and traceability from plantation to export. Harvested pineapples arrive at the packing facility, where they are immediately received, logged, and transferred to automated washing lines. Here, controlled water pressure and food-grade sanitizing systems remove field residues while protecting the fruit's natural wax layer. The pineapples then move through optical and manual inspection stations, where size, weight, crown condition, and external defects are carefully evaluated. Approved pineapples are directed to packing lines, where workers place them into ventilated cartons designed to optimize airflow during cold chain transport. Each box is labeled with full traceability data, including origin, lot number, and packing date. Finally, pallets are stabilized, wrapped, and transferred to cold storage, maintaining precise temperature control to safeguard quality throughout global distribution. The Pronat tomato concentrate operation follows a tightly controlled industrial process designed for high capacity and product consistency. Harvested tomatoes arrive continuously at the unloading zone, handling up to 500-600 tons per day through approximately 250 daily entries. After reception, the tomatoes pass through automated selection lines before enzymatic deactivation, using cold break technology at 65 to 70 degrees C or hot break processing, depending on the final product. The pulp then moves to screening and Apollo filtration systems to remove skins and seeds. Concentration is carried out in venous evaporators, evaporating up to 60 tons of water per hour with optimized energy efficiency. The final stage includes sterilization and fully automated filling on 5 parallel lines, with continuous monitoring of physical-chemical parameters to ensure uniform quality. Tomato paste is a thick, concentrated product made from fully ripened tomatoes and serves as a key ingredient in sauces, soups, and many prepared foods. The manufacturing process begins with harvesting ripe tomatoes from the field, followed by sorting to remove damaged or unripe fruit. The selected tomatoes are thoroughly washed to eliminate dirt and foreign matter. They are then crushed using industrial fruit grinders to produce tomato pulp. The pulp undergoes preheating to deactivate enzymes, then is refined to separate skins and seeds from the juice. The refined tomato juice is fed into evaporators, where water is removed under controlled temperature and vacuum conditions. This concentration step increases solids content and develops the characteristic texture of tomato paste. Once the desired concentration is reached, the paste is sterilized to ensure microbiological safety and product stability. Finally, the hot paste is aseptically filled into sterile bags inside drums, preserving quality, flavor, and shelf life for industrial and culinary use. In 2018, Earl Bidwell implemented a highly mechanized apple harvesting process dedicated to cider production, enabling the efficient collection of more than 1,000 tons of apples from a 21-hectare orchard. The system is designed specifically for processing apples, where productivity, consistency, and logistical coordination are prioritized over cosmetic appearance. The operation begins with mechanical tree shaking. A tractor-mounted shaker equipped with a clamping mechanism grips the trunk or main branches of each apple tree. Controlled vibrations, optimized in frequency and amplitude, are applied to dislodge ripe apples. The fruit falls directly to the ground while minimizing stress on the tree structure and root system. This method allows rapid harvesting across large areas and significantly reduces labor requirements compared to manual picking. Once the apples are on the ground, a second machine enters the workflow to organize the fruit. A blower vehicle uses directed high-velocity airflow to move scattered apples into uniform rows or concentrated windrows between the trees. This step is critical for improving collection efficiency, ensuring that the subsequent harvesting machine can operate continuously without unnecessary stops or overlaps. The next phase involves a specialized ground apple harvester. This machine uses rotating brushes and pickup rollers to lift apples from the soil surface onto a conveyor system. Integrated cleaning components remove leaves, soil, and debris, ensuring that only apples are transferred onward. The cleaned fruit is conveyed into an onboard storage hopper, allowing uninterrupted harvesting over long distances within the orchard. In the final stage, the apples are transferred from the harvester's hopper into transport trucks positioned at the field edge. These trucks then deliver the harvested apples directly to the cider production facility. Rapid transport helps preserve raw material quality and ensures a steady supply for pressing and fermentation. This fully mechanized harvesting chain allows Earl Bidwell to manage large volumes with precision and speed while maintaining consistent raw material quality. By synchronizing tree shakers, blowers, harvesters, and transport vehicles, the operation achieves high daily throughput, reduced labor dependency, and reliable performance, key factors for large-scale cider apple production. The Peterson Farms applesauce plant represents a new generation of high-precision food processing. Apples arrive from GAAP-audited growers across the United States, hand-harvested and carefully stored in controlled atmosphere rooms that slow ripening and preserve orchard-fresh quality. When production is scheduled, each batch is released, inspected, and directed onto the applesauce line. The fruit is cleaned, washed under high pressure, and visually inspected before entering advanced chopping and refining systems. Here, apples are transformed into a smooth sauce, while peels and seeds are removed and recycled as organic fertilizer. The applesauce is then pasteurized above 180 degrees Fahrenheit, a critical food safety checkpoint. After blending and metal detection, the product moves through automated filling, sealing, X-ray inspection, chilling, and robotic packing. Every step is monitored to ensure consistent quality, safety, and taste, delivering applesauce from farm to table with confidence and care. Avocado EPZ operates as a fully integrated avocado processing facility, combining fresh fruit export with advanced avocado oil production. Within this operation, organic avocados are transformed into premium extra virgin oil for food applications and refined crude oil for cosmetic use, positioning the plant as a global leader in organic avocado oil processing. Fresh fruit arrives from certified partner farms and is carefully weighed, inspected, and graded by size. The avocados then move through an efficient packing line, where they are prepared to meet strict export standards for international markets. Fruit not selected for fresh export is redirected to the oil processing line, ensuring maximum use of every harvest. During oil extraction, organic byproducts are recovered and converted into biofertilizer and biogas. The fertilizer is returned to farms to support soil regeneration, while biogas supplies renewable energy for plant operations. Alongside processing, Avocado provides continuous farmer training in organic cultivation, global GAAP compliance, and crop management. Through this closed-loop, technology-driven system, Avocado delivers consistent quality while supporting sustainable agriculture and long-term value creation across the supply chain. Inside Kikuzi quality avocado production reveals a fully integrated avocado operation, built to meet the demands of modern global markets. At Kikuzi, avocado is more than a crop. It is a long-term investment in nutrition, sustainability, and traceable food systems. The estate focuses on Haas and Pinkerton varieties, selected for their superior nutritional value, consumer preference, and reliable post-harvest performance. Today, Kikuzi manages roughly 800 hectares of avocado orchards, with a clear strategy to expand to 200 hectares. Every stage of production is governed by a robust traceability framework. From nursery propagation to orchard management, each activity and input is recorded, allowing every fruit to be traced back to its source. Seedlings are grown in-house to maintain complete control over rootstock and scion quality, ensuring consistency from planting through to export. Site selection emphasizes soil structure, drainage, and dependable water access, as avocado trees, particularly Haas, are highly sensitive to excess moisture. Land preparation follows a precise sequence: clearing, deep soil breaking, spacing layout, irrigation installation, soil testing, and controlled planting. Phosphorus-based fertilizers are applied strictly according to soil analysis, promoting healthy root development while protecting the surrounding environment. Water management relies on strategically built dams that capture runoff rainfall, extending water availability well beyond the rainy season. Pruning programs are applied to optimize sunlight penetration, airflow, and fruit development, while reducing pest and disease pressure. Harvesting is conducted under strict food safety protocols, using sanitized tools and protective equipment. Fruit moves rapidly from field to packhouse, where segregation, maturity checks, cold chain control, and FSSC 22000 certified processing preserve quality within 24 hours. From seedling to shipment, Kikuzi delivers Kenyan-grown avocados with consistency, transparency, and international-grade quality. This pomegranate processing line is designed to deliver precise, high-throughput grading based on color, diameter, weight, and overall fruit quality. After unloading, pomegranates are conveyed through a washing and drying section to remove dust and field residues. The clean fruit then enters an automated inspection zone equipped with optical cameras and sensors that analyze external color uniformity, surface defects, and ripeness indicators. Next, electronic sizing units classify each pomegranate by diameter, while integrated load cells accurately measure individual weight. Based on predefined parameters, the system automatically diverts fruit into multiple output channels, corresponding to specific market grades. Any fruit failing quality thresholds is rejected or redirected for processing use. The entire line operates continuously, ensuring consistent sorting accuracy, minimal manual handling, and optimal product presentation for fresh market or industrial applications. In 2009, ultra-high-density olive groves marked a turning point in modern olive oil production, combining advanced agronomy with full mechanical harvesting. These super-intensive plantations are designed with narrow row spacing and uniform tree architecture, allowing specialized harvesters to move continuously through the groves, shaking and collecting olives with exceptional speed and precision. This system significantly reduces harvest time, labor dependency, and fruit exposure to oxidation. The focus extends beyond harvesting efficiency to total quality control in the field. Olives are monitored closely to determine their optimal ripening stage, when aromatic compounds and oil yield reach the ideal balance. More than 5,000 hectares of company-owned groves are cultivated, using modern irrigation, pruning, and nutrition strategies to ensure uniform fruit development across large areas. Harvesting and processing are tightly synchronized. Olives are transported to the mill immediately and processed on the same day using cold extraction techniques. This rapid transition from tree to almazara preserves volatile aromas, limits enzymatic degradation, and protects the oil's sensory profile. By controlling every stage, from cultivation and mechanical harvesting to cold milling, delivers an extra virgin olive oil defined by fresh fruit character, aromatic intensity, and consistently high quality. Grupo Olicola Jaén operates a vertically integrated olive oil production system based on advanced agronomy and Industry 4.0 milling technology. Olive groves are managed with controlled vegetal cover to prevent erosion and improve soil structure, while fruit is harvested early at optimal ripeness. Olives are cleaned, weighed, and analytically assessed on-site to determine moisture, oil yield, and acidity. The smart mill monitors each processing stage in real time, optimizing extraction efficiency and product quality. Daily capacity exceeds 1 million kilograms of olives. Byproducts are processed through a dedicated biomass and pomace treatment plant, supporting energy recovery, waste valorization, and a fully circular production model. Farms operate 6 SQF-certified processing facilities equipped with IQF freezing lines, fresh-cut apple systems, juice and sauce production, and controlled atmosphere storage. Advanced sorting, traceability, and cold chain technologies enable high-volume processing, long-term storage of over 131 million pounds of apples, and consistent food safety compliance. Jagat 300 is a tractor-mounted harvester engineered for efficient mechanical harvesting of American blueberries. Requiring approximately 80 horsepower, it is optimized for first, second, and third pickings. The machine integrates patented 920 gentle shaking heads, ensuring effective fruit detachment while minimizing damage to berries and bushes. Advanced sensor systems automatically center the harvester in the row and lift the frame when ground contact is detected, protecting conveyors and ridges. Hydraulic controls, available via panel or wireless remote, allow precise adjustment of shaking intensity, conveyor speed, fan power, wheel alignment, and platform positioning, ensuring stable performance across varying field conditions. At Patron, the tequila making process begins with carefully selecting mature blue Weber agave. The agave is chopped and loaded into brick ovens, where water steam is injected in cycles, followed by periods of rest. The porous ovens naturally lose heat, so re-injection ensures the agave cooks evenly, converting complex starches into fermentable sugars. Once cooked, the agave is pulled out and shredded. The sweet fibers are then crushed, using traditional tajonas, 7-ton stone wheels historically pulled by donkeys, which extract the rich agave honey. This liquid, full of natural sugars, is transferred into pinewood fermentation tanks. The cap of the fermenting must is broken and mixed to ensure even fermentation, allowing both juice and fiber to contribute to the final flavor. After fermentation, the mixture moves to copper pot stills for distillation. Heat is applied slowly, and alcohol vapors rise through the copper coils. These coils help refine the spirit, removing impurities while concentrating the alcohol and enhancing smoothness. Producing tequila in such small batches is labor-intensive, but this careful method ensures each bottle captures the authentic agave flavor, resulting in a naturally perfect and balanced Patron tequila. At the NBF facility, avocado oil manufacturing follows a tightly controlled industrial sequence. Harvested avocados are first stored and selected by quality, then processed through mechanical pressing. The oil undergoes thermobatide treatment, first spinning, refining, and extra virgin extraction. Final stages include precision filling, labeling, and preparation for distribution. When the olive harvest season arrives, a new operational challenge takes shape. Long working days, demanding terrain, and a clear objective define each campaign to complete the harvest efficiently and correctly. Early morning sets the pace, with low temperatures and limited light requiring controlled machine operation and precise coordination. As daylight increases, working methods evolve, and productivity accelerates. There are no speeches, only skilled operators, synchronized workflows, and equipment performing reliably hour after hour. In this environment, machinery becomes an integral part of the team. Well-engineered tools help maintain consistent output. Reduce operator fatigue, and respond effectively when workloads intensify. Technology does not replace expertise, but it enhances precision, stability, and continuity throughout the entire olive harvest campaign. Harvesting sunflower efficiently requires specialized equipment, and the Claas choreo header is engineered precisely for this task. Originally developed as a versatile row crop header, choreo proves that it is not limited to maize alone but also delivers highly effective sunflower harvesting performance. Its design reflects Claas's continuous response to evolving market demands and modern agricultural practices. Technically, the choreo header is optimized for clean, controlled intake of sunflower stalks and heads. The robust gathering points guide plants smoothly into the header, minimizing losses caused by shattering or premature seed drop. Reinforced construction and wear-resistant components ensure reliable operation even in tough field conditions, where sunflower stalks can be fibrous and uneven. The header maintains a consistent cutting and feeding process, which supports stable throughput and uniform crop flow into the combine. Another key advantage lies in adaptability. Claas choreo headers are available in multiple row configurations and can be precisely adjusted to match row spacing, crop density, and field layout. This flexibility allows operators to maintain optimal harvesting speed while protecting seed quality. The synchronized interaction between header, feeder house, and combined threshing system ensures efficient separation with reduced mechanical stress on the seeds. By continuously developing its harvesting attachments, Claas demonstrates a clear commitment to innovation. With choreo, farmers gain a reliable, multi-crop solution that combines technical precision, durability, and harvesting efficiency, making sunflower harvest faster, cleaner, and more economically sustainable. In 1999, Almarai introduced its first range of fresh juices, supported by a purpose-built, high-technology production infrastructure. At the initial stage, precise pasteurization of all ingredients to sterilization levels, ensuring microbiological safety while preserving flavor. The treated juice is transferred to insulated tanks, then fed into automated filling lines. Packaging and pallet stacking are performed by industrial robots for consistency and efficiency. Finished products are rapidly cooled and stored at controlled temperatures between 3 and 5 degrees Celsius. A fully refrigerated logistics network then delivers the juices to markets, maintaining freshness and quality throughout distribution. Located in West Texas, the best-made pickle farm has maintained full vertical control of cucumber production for over 40 years. Operating up to 71 fields annually, the farm grows non-GMO cucumbers using precise planting depths, sand management, irrigation, and mechanical cultivation. Bee-assisted pollination is critical to yield optimization. Harvesting is fully mechanized, cutting and lifting entire vines, separating fruit via rollers and conveyors. Post-harvest handling integrates flume washing, chlorinated sanitation, and manual defect grading to maintain uniform quality and processing efficiency. The Vogel Engineering Celery Harvester is designed to mechanize one of the most labor-intensive stages of vegetable production. The machine integrates precise cutting, lifting, and conveying systems to harvest celery efficiently while minimizing crop damage. Adjustable cutting units ensure consistent stalk length, while synchronized belts guide the celery smoothly from the soil to the collection area. Robust steel frames, hydraulic drives, and terrain-adaptive components allow stable operation in varying field conditions. By combining mechanical accuracy with high throughput, the harvester improves productivity, reduces manual labor, and delivers uniform harvest quality suitable for large-scale commercial farming. The Vogel Engineering Squash Harvester is a purpose-built machine designed for efficient, large-scale squash harvesting. Developed in 2017, the system is capable of handling multiple squash varieties, including acorn, butternut, buttercup, and Hubbard. A wide 20-foot pickup header allows the machine to harvest 8 30-inch rows simultaneously, significantly increasing field productivity. Carefully engineered lifting and conveying mechanisms collect the squash while minimizing impact and surface damage. With robust construction and precise material handling, the harvester delivers consistent performance, reduced labor demand, and reliable operation under demanding agricultural conditions. Designed for efficient field harvesting, the EX17 Pro Harvester Wagon provides a rugged, labor-saving solution. Its 28-foot hydraulic conveyor adjusts in height and position, moving produce directly to the packer. Built on an 8-ton chassis, it reduces manual handling, improves workflow, and protects both crops and workers throughout the harvest cycle. Guinness Brewery at St. James's Gate is a place steeped in history and pride, carrying forward centuries of brewing tradition. Today, the brewery blends this heritage with modern technology, yet the main Guinness recipe, malt, water, hops, and yeast, remains unchanged. Barley is roasted to precise color and pH levels, then mashed in the brewhouse to produce a sugary extract that feeds the legendary Guinness yeast. After fermentation, hops are added and the beer matures under careful monitoring. Every pint follows strict quality standards, including head height, gas pressure, and temperature, ensuring the consistent taste Guinness is known for worldwide. Innovation continues at the pilot brewery, where new beers are developed while honoring centuries-old recipes. Gwyn. Scotch whiskey begins its journey with carefully selected grains, usually barley, which are malted, mashed, and mixed with water to extract fermentable sugars. The resulting liquid, called wort, is transferred to fermentation vessels where yeast converts the sugars into alcohol, creating a wash. This wash is then distilled in copper pot stills, concentrating flavors and alcohol content while removing impurities. After distillation, the spirit is filled into oak casks for maturation, sometimes for many years, allowing it to develop complexity and character. Finally, the whiskey is carefully blended, diluted to bottling strength, and prepared for tasting and enjoyment. Stone-pressed olive oil production at Tinklik combines a time-honored method with modern control technology. Carefully selected olives are cleaned and slowly crushed using traditional stone mills, allowing gentle cell rupture and minimal heat generation. This preserves natural aromas, polyphenols, and nutritional value. The resulting olive paste is then layered and prepared for separation, where controlled extraction techniques ensure precise oil recovery without excessive heat or mechanical stress. By integrating traditional stone pressing with contemporary processing technology, the system delivers olive oil with high purity, stable quality, and a well-balanced sensory profile, reflecting both heritage methods and modern production standards. Krone Swadro rotary rakes are engineered for high-performance forage harvesting under demanding field conditions. The product range is designed to deliver consistent swath formation, even in heavy silage, while minimizing contamination and crop losses. A core technical feature across all Swadro models is the lift tine system. Each tine arm is equipped with double tines featuring a 10-degree angled tip, allowing the crop to be lifted cleanly while maintaining increased ground clearance and protecting the turf. At the heart of each rotor is the hardened Duramax cam track, manufactured from specially tempered cast iron and enclosed within a fully sealed cam housing. This design ensures maintenance-free operation and long service life. The tine arms are guided by massive, permanently lubricated guide rollers that provide precise control and stability under high loads. Rotor height adjustment is available with millimeter-level accuracy, either mechanically or via an optional electric control from the tractor cab. The three-dimensional suspension system, combined with optimized wheel positioning, allows the rotors to follow ground contours precisely. This results in clean raking, reduced soil contact, and consistently high-quality forage for silage, hay, and straw production. Modern agriculture relies on a wide range of machinery designed to improve efficiency, reduce labor, and maximize yield. Key equipment includes tractors, the backbone of most farms, used for plowing, planting, and towing other machines. Planters and seed drills ensure precise sowing, while cultivators and harrows prepare and aerate the soil for optimal crop growth. For harvesting, specialized machines dominate the fields. Combine harvesters efficiently gather cereals, separating grain from chaff in a single pass. For forage crops, mowers like disc or drum cutters, rotary tedders, and rakes collect and prepare hay or silage. Balers, both round and square, compress harvested crops into manageable bales for storage and transport. In addition, silage harvesters, such as self-propelled forage harvesters or choppers, handle large-scale green fodder collection, often paired with transport trailers to move material to storage. Precision sprayers and irrigation systems ensure crops receive the right nutrients and water efficiently. Today, modern farms integrate technology like GPS guidance, automated controls, and telematics to monitor performance, reduce waste, and optimize productivity, making agricultural machinery smarter and more sustainable than ever before. Suerte Tequila is produced using the traditional Tahona method for 100% of its production, preserving authentic tequila craftsmanship. Slow-cooked blue agave is crushed under a massive volcanic stone wheel, allowing the gentle extraction of agave juices without excessive fiber damage. This low-impact process maintains natural sugars and aromatic compounds. The extracted juice and fibers are then fermented naturally, developing complex flavors before careful distillation, resulting in a smooth tequila that reflects heritage, precision, and respect for time-honored production techniques. The Vermeer 605S Rancher Baler introduces a new chapter in the Rancher legacy, engineered for durability, simplicity, and consistent bale quality. At the front, a camless pickup design significantly reduces wear at high stress points, requiring maintenance on only 2 bearings. Polyriser stripper bands and rubber-mounted pickup teeth improve crop flow and longevity, even in stringy conditions. A 91-inch wide pickup paired with a rotor ensures smooth feeding into the chamber. Requiring just 75 horsepower to form a 6by 5-foot bale, the baler offers flexible PTO options and robust driveline protection. Bale density and performance data are managed in-cab via the Atlas Pro control system, enhancing operational efficiency and decision-making.